Hello students, myself Dhruva Dikshit working as assistant professor in Kite Group of Institutions. In today's lecture, I will teach you about the curve tracing. I will explain the stepwise procedure. First of all, we have to find out the symmetry about any axis or line. So if the equation of the curve contains the even power of y, then curve is symmetric about the x-axis. If it contains the even power of x, then it is symmetric about the y-axis. If we replace x by y and y by x and the equation of the curve remains unchanged, then the symmetry about the line y equal to x. For opposite quadrant, we have to replace x by minus x and y by minus y, and if the equation of the curve remains unchanged, then there is a symmetry in opposite quadrant. Now the step 2, we have to check that whether the curve passes through region or not. If the equation of the curve contains the constant term, then it does not pass through region. If there is no constant term, then the curve passes through region. For step 3, we have to find out the equation of tangent at origin. Equation of tangent is obtained by equating the lowest degree term of the equation to 0. So the two cases arises. In case 1, if the equation is just like y square equal to 0, then that equation is real and constant. So there is a cusp at the origin. In the second case, we obtained the equation like y equal to plus minus x, equation of tangent like y equal to plus minus x, then it is real and distinct, and there is a node at the origin. Basically, the cusp and the node are the double points. The double points are the points from which the curve passes 2 times. Now the step 4. Here we have to find out the asymptotes. The question arises that what is the asymptote? Basically, asymptote is the tangent to the curve at infinity. If this is the curve, then this is the asymptote. This is a tangent to the curve at infinity. And what is the need? Why we are trying to find out the asymptote? Because the curve cannot go beyond the asymptote, so it is very fruitful in curve tracing to find out the asymptotes of the curve. Now the asymptote parallel to x-axis can be obtained by equating the coefficient of highest power of x to 0. And asymptote parallel to y-axis can be obtained by equating the coefficient of highest power of y to 0. Now the step 5. We have to find out the point of intersection with x and y-axis by putting x0, y0. In step 6, we have to find out the region in which the curve lies. To find out the region, we have to solve the equation for y and neglect or reject all those values of x which makes y imaginary. It is very easy to summarize or memorize this process by SOAPR, where S is the symmetry, O is the origin, A asymptote, P point intersection, and R is the region. Now let's see an example. We have to trace the curve y square 2a minus x equal to x cube. For this, first of all, we have to find out the symmetry. As the given equation of curve contains the even power of y, so the curve is symmetric about x-axis. Now this step 2, we have to find out that whether the curve passes through region or not. Clearly, it does not contain any constant term, so the curve passes through region. Now step 3, we have to find out the tangent at origin. For this, we have to equate the lowest degree term to 0. That is 2ay square minus xy square equal to x cube. So the lowest degree term is 2ay square. This implies y square equal to 0. That is the equation of the tangent is real and constant. So we obtain the cusp at the origin. Now we have to find out the asymptotes. Asymptote parallel to x-axis As the coefficient of highest power of x is unity, that is the constant, so there is no asymptote parallel to x-axis. Now we have to find out the asymptotes parallel to y-axis. Equating the coefficient of highest power of y to 0, we get x equal to 2a. So x equal to 2a is asymptote parallel to y-axis. Now the step 5. We have to find out the point of intersection with x and y-axis. And it is clear that the only point is 0, 0. That is, the curve only passes through region. Now the step 6. We have to find out the region. If y equal to x and root of x by 2a minus x, then if x is less than 0 or x is greater than 2a, then the value of y is imaginary. So we have to reject these values, and by this tracing procedure we obtain the curve as cusp by the equation of tangent, asymptote x equal to 2a, point of intersection 0, 0. So we obtain the cusp. Now the next question, we have to trace the curve y square a minus x equal to x square a plus x. For symmetry, as the equation contains even powers of y, so the curve is symmetric about x-axis. In step 2, we have to find out that the curve passes through region or not. As the equation contains no constant term, so the curve passes through region. Now the step 3, we have to find out the tangent at origin. Equating the lowest degree term to 0, we obtain y equal to plus minus x. And this is real and distinct, so there is a node. In step 4, we have to find out the asymptotes. Asymptote parallel to y-axis can be obtained by equating the coefficient of highest power of y to 0, that is x equal to a. We can see here that there is no asymptote parallel to x-axis, as the coefficient of highest power of x is 1. Now in step 5, we have to find out the point of intersection. When we put x0 and y0, we obtained the points 0, 0 and minus a0. Now in step 6, we have to find out the region in which the curve lies. So when x greater than a or x less than minus a, y is imaginary. So no part of curve lie beyond x greater than a and x less than a. The shape of the curve is shown as in figure. Here y equal to plus minus x are the tangent, x equal to a is the asymptote, and this is the node. And in the next lecture I will discuss the tracing in polar coordinates. So thanks.